Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been once again chosen from the same book, that is Modern Physics by Kenneth S. Crane. Okay. As usual, we first come to its statement. Okay. An electron is trapped in a one-dimensional region of width 0.050 nanometer. Nano meaning 10 to power minus 9. Okay. Find the three smallest possible values allowed for the energy of the electron. Okay. As usual, we first come to its toolkit. Okay. Helping tools. Tool number 1. Dear students, this tool has also been used in our previous problem. Okay. Energy levels for a particle in a box. Okay. En. Energy levels for a particle in a box En is equal to Pn square over 2m, where Pn is the magnitude of momentum divided by 2m, where m is particle's mass. Okay. This expression alternatively becomes equal to n square h square divided by 8m capital L square, where h is Planck's constant. Okay, its value is given in another table which is shown in another tool. Okay, divided by 8m capital L square. M is the particle's mass and L is the width of box. Okay, capital L is the width of box. This expression alternatively becomes equal to n square pi square h cut square. Okay, this is not h. This is h cut, and h cut is equal to h over 2 pi. Okay, divided by 2m capital L square. Okay, here 8 has been converted into 2. Why? Because if we revert to h, that is if we use h over 2 pi in place of h cut, then pi square will be cancelled with pi square, and 4 will be divided and 8 will become 2. Okay, there is no difference in these two equivalent expressions. The only difference is that here, in place of Planck's constant h, we have used the value h cut, which is equal to h over 2 pi. Okay, Planck's constant divided by 2 pi, where n is quantum number, n equal to 1, 2, 3. Okay, this tool has also been discussed in previous problem, so it is enough about this problem, about this tool. Okay, next tool number 2 has also been used several times in our previous problems. From this table we will use the value of electron, that is in place of mc square we will use 0.511 million electron volt, or if we want to convert it in electron volt, then we will use 511,000 electron volt. Dear students, tool number 3 has also been used several times in our previous problems. Okay, From this tool, speed of light c equal to 2.998 into 10 to power 8 meter per second will be used. Okay, moreover, Planck's constant, which has been given into alternate system of units, will be used. Okay, here we will use its second equivalent value. Rather, we will not use this value of H and C. Rather, we will use combined effect of H and C, that is, which is given here in the second last line. Okay, Hc equal to 1240 electron volt nanometer or million electron volt femtometer. Okay, we will use this first equivalent expression, that is electron volt nanometer. Okay, moreover, yes, we will use this value. Okay, mass of electron, no, here in place of this we will use a previous tool in which yes, these values will not be used. This value is usable, then Planck's constant, this value is usable, and alternate use of these two values is this value, combined effect Hc equal to 1240 electron volt into nanometer. Okay, so now we come to its solution. Okay, solution. We know that smallest energy requires n equal to 1 in equation En equal to n square h square over 8 ml square. Okay, we once again go back to this expression. Okay, from here we have not used actually this first equivalent expression, and we have not used this third equivalent expression. Okay, we have used this intermediate arrangement. Okay, En is equal to n square h square over 8 ml square. Okay, En is equal to n square h square over 8 ml square, and here for smallest energy n will be definitely 1. Okay, because least value of n is equal to 1. We know that smallest energy requires n equal to 1 in equation En equal to n square h square over 8 ml square. This implies that E1 equal to h square over 8 ml square. What we have done, we have used 1 in place of n. Okay, when we use 1 in place of n, then this expression will become this. Okay, because 1 square is equal to 1 and En will be converted into E1. Okay, E1 is equal to h square over 8 ml square. Okay, in the next step, what we have done, we have made an arrangement which will facilitate us in reaching our desired solution. Okay, what arrangement? We have actually multiplied and divided it with c square. Okay, we can do this. By doing this, our expression will not be suffered. Okay, because we can say that c square will be cancelled with c square, but actually the purpose of using this arrangement is that out of these two c square, at one place we will use equivalent value of c in terms of meter per second, which is 2.998 into 10 to power 8 meter per second. Okay, so E1 will become equal to h square c square can be written as in a combined form, that is hc whole square divided by m divided by 8, and c square has been written with m and l square has been written separately as a multiplying factor with this. Okay, so this is just a rearrangement of these parameters. Okay, hc whole square divided by 8 into mc square into l square. Okay, in the next step, as I had said that in a table where value of c separately is given, speed of light and value of Planck's constant h is also given in two equivalent system of units, and combined value of hc is also given. Okay, so here what we have done, we have used combined value of hc. Okay, we have not separately used values of Planck's constant c, Planck's constant h and speed of light c. Rather, we have taken combined result, that is after multiplying both these, result becomes 1240 electron volt into nanometer. Okay, so we have used that combined value. Okay, moreover, in place of mc square we have used 0.511 million electron volt. So in place of million we have used 10 to power 6. Okay, because million stands for 10 to power 6. So it is our discretion whether we used 0.511 million electron volt or 0.511000 electron volt. Okay, so here we have used electron volt, and in place of writing it as 511000, we have written it as 0.511 into 10 to power 6 electron volt multiplied by 0.050 nanometer whole square, which is given in the statement. Okay, width, okay, of box. In the next step we have just simplified. Simplification means we have taken square of this value, that is 1240. Okay, if we multiply 1240 with another 1240, then we will get 1537600. Okay, moreover electron volt will become square. Okay, because moreover nanometer will also become in square. Okay, over divided by what we have done, we have multiplied 8 with 0.511 into 10 to power 6 into 0.050 into 0.50. Okay, so in other words we can see that first we have multiplied 0.050 two times, and then we have multiplied it with 511000, and then we have multiplied it with 8. Okay, after multiplying all these values, the combined value becomes 10,220 electron volt nanometer square. Okay, here dear students, nanometer square will be cancelled with nanometer square, and 1 electron volt will be cancelled from electron volt square, and we will be left only with electron volt, simply electron volt raised to power 1. Okay, so its answer has become equal to 150.45 electron volt. Okay, so E1 has become equal to 150.45 electron volt. Similarly, we can find the value of E2 by using n equal to 2. Okay, so when we will use n equal to 2, then E2 will become, in place of n, when we will use 2, it will become 4. Okay, because 2 into 2 is 4. 4 h square over 8 ml square is equal to h square over 2 ml square into c square over c square. Okay, 4 and divided by 8 has become equal to 2. So we have again multiplied and divided by c square, and in the next step, once again hc whole square has been written. Okay, h square c square has been written in this form. Okay, divided by 2 mc square into l square. Okay, c square has been written with mc square so that value of mc square may be taken from toolkit. Okay, where for electron, in place of mc square value 0.511 million electron volt or 511000 electron volt value is given. Okay, So here in the next step we have used combined value of HC from the toolkit, which is 1240 electron volt dot nanometer whole square divided by 2 into 0.511 into 10 to power 6 electron volt into 0.050 nanometer whole square. So when we will multiply 1242 times, then it will become 1537600 electron volt whole square nanometer whole square divided by 2555 electron volt into nanometer square. Okay, that is to say, first we will multiply 0.050 with another 0.050, and then we will multiply it with 511000, and then we will multiply it with 2, and hence after multiplying all these values, the combined value will become 2555. Okay, now here nanometer square will be cancelled with nanometer square, and 1 electron volt will be subtracted or will be cancelled from electron volt square, so we will be left with only 1 electron volt. Okay, so our value of E2 will become 601.8 electron volt. Similarly, when we use n equal to 3, then value E3 becomes equal to 9h square over 8 ml square. Okay, because square of 3 is 9. Okay, so this alternatively becomes equal to 9h square over 8 ml square into c square over c square. Okay, in the next step we have written hc whole square in a combined manner, and we have written c square along with m, and written L square separately as a multiplying factor with this MC square. Okay, in the next step 9 is same as it is, however in place of HC we have used combined value of HC, which is given in the tool. Okay, 1240 electron volt into nanometer whole square divided by 8 into 0.511 into 10 to power 6 electron volt into 0.050 nanometer whole square. Okay, now in the numerator, when we will multiply 1242 times, and after multiplying it with 2 times we multiply it with 9, then combined effect of these three operations become 13838400 electron volt whole square nanometer whole square divided by what we have done. We have first we have multiplied 0.050 with itself. Okay, we have multiplied 0.050 with 0.050, then we have multiplied it with 511000, then we have multiplied it with 8, and combined effect of all these operations has become equivalent to 10,220. 10,220, yes, 10,220 electron volt into nanometer square. Okay, here nanometer square will be cancelled with nanometer square, and 1 electron volt will be cancelled from electron volt square, and so our value of E3 will become equal to 1354.05 electron volt. Okay, E3 has become equal to 1354.05 electron volt, and this is the end of our problem. Till next problem, till next video, Allah Hafiz. Okay.